Yeah. Uh-huh.
I guess that's good and bad. I don't end up like, no, I knew what I was going to do, and everyone else seemed like they had a pretty good idea.
Did you open up the Xcode project or like a?
Oh wait, we found it. We were double. Okay. Just ignore that. You're not recording, yeah?
We are recording.
Oh, great.
Awesome, but it never gets questioned.
Can you ask some question?
You can ask a question. It's on video.
Okay. Well, it might help someone else.
Okay.
So I have this page, and I wanted how long do you think it's going to take to fix in the landscape? So what's happening is, I haven't messed with this yet, so I'm doing the landscape like now. So it's just a picker that lets you like zoom in on a scroll view and do some stuff.
Yeah.
So when I go, it's fine with the table and my button on the bottom, this thing gets shifted over and my scroll view goes away. What would you recommend to get this?
Put the whole thing inside of another scroll view, so that you can scroll around to get access to it. Because I mean that UI,
So like this
UI where you have buttons built on top of that, it's not meant for a landscape.
Yeah,
mode.
right.
So put it in a scroll view so that you can go up and down with it, so that it doesn't break the UI.
Just put a scroll view from the storyboard in there as the container for what's here right now. I don't have to do anything else than that, you think?
Well, every time that you add something there to the view, you want to add it as a sub view to the scroll view instead of a sub view to.
So I can just do it programmatically then.
Yeah, you can.
Okay, so basically just leave it. So I'm doing most of it programmatically, and I'm just adding views. Like I add
The other thing to do is relay it out, and you want to get a notification whenever you turn to landscape mode, and switch the layout switch you're in, right? So put buttons over here, and the image now on the right hand side, right?
Okay.
So auto constraints won't do that for you. You have to get a notification and then relay out the view.
Have you seen anything on what's best practice in that case, or would it be better just to design your UI differently?
It's better to design the UI.
Okay.
If that's not meant for landscape
Can
mode,
you turn off landscape?
you can absolutely turn off landscape mode, and you can do it maybe only for that view.
Okay.
Right, if you need to.
Okay, I got that.
So that is a possibility.
Okay.
Yeah.
And is this background? See how it's gray? Is it default white usually for
It
this
usually
type of thing?
defaults white.
Okay. I mean, I changed it to gray. I just didn't know if there was like a standard for that. It's
It usually
white?
defaults to white, no border.
Okay.
Yeah. Okay, how's everybody doing? Well, I get a thumbs up, and a lot of people that are like, "What the hell am I doing here?" That's okay. Great, awesome, excellent. I like to hear it. I feed off of that. This is good. No? One guy laughed. I'm good with that. That's fine. All right, moving on. Agenda. Questions about core data. How's everybody doing with it? It's an extra credit, so everybody's probably like, I haven't even looked at that yet. I'm trying to do what's on the project. But are there any questions on it? Anything? Ask? Do? No? All right, fair enough. So today what we're going to talk about is notifications. I'm going to get into blocks and concurrency. I called it multi-threading. It's really concurrency. It is multi-threading in a way, and we'll see how that is. I'm going to talk very briefly about Objective-C++ because we only need to talk about it very, very briefly. And then we're going to go straight into an intro to CoreAudio and demo a setup project if we have time using CoreAudio, right? So we are going to, hopefully with this lecture, end our UI discussion, okay? Until we talk about OpenGL next week, right? And that's going to be very, very quick. And I'm going to give you a bunch of wrapper code, right? A monkey could use it. Fair enough? Okay.
Can't use it. What does that make us?
You're right, I shouldn't have said that. I was trying to say that I made it very, very easy to use, okay? And if it's not, you can blame me, okay? Blame the architect. Okay, so Notifications. Notifications are what we use to kind of broadcast something when your model changes, right? So your underlying model changes, and everyone that is using your model, let's say it's a user interface or it's a table view, wants to tune into that notification that, hey, something has changed so that I need to change now, right? Because your model should work regardless of what view controllers are connected to it. It doesn't want to have anything specific about the view controllers that are connected to it for it to function, right? So for example, core data, when we're looking at core data, that's just a database. It doesn't need to know that it's connected to a table view controller, right? But if that underlying model changes, it needs to create a generic notification so that anybody who's displaying data from that database can change, right? And there's a various, other notifications that you can get in iOS. Like, so if someone changes their location, right, you'd want to be notified that location has changed. And you can sign up for notifications when someone has moved, say, 50 feet, or I want to get notified when they move a mile, or something, et cetera, like that. All right, so notifications are used in that as well. So if we're going to carry on with our core data example, last time when we did the core data example, in the view will appear for the table, I basically queried the database for everything that was there and updated myself, right? And that was a really, really poor implementation, right? Every time that view loads, I'm going to go ask the database for everything that's in it so that I can reload all of the data in my table, right? It would be much better to say whenever that context, right, whenever that database that we're using has been modified, then I want to reload the table, right? So this is a perfect use of Notification Center. So the way that we do that is we basically go and get a handle to the default notification center. So the default notification center where everything gets broadcast from in iOS, from this default center, notification center, right? So is everybody okay with this right here? This method, default center? I'm calling a function on the NS notification center class, right? That's a class function, right? And what it returns is an instance. Class variables almost always return an instance to something else. Or they've instantiated it, or you get another instance or something, right? Just like the same when you call on NS string with format, you're calling a function on that class. So right here, what I'm doing is I'm adding observer, which is myself, the view controller that I am. I want to receive messages, or I want to tune into this radio station for whenever my NS managed object context did save notification. So whenever something is saved inside of my database, I want to make sure that I alter what I'm showing on the screen, right? And I'm going to do that for the object, this managed object context, right? So I'm going to access the notification center. And when this happens, when I get a did save notification from this context, which is the managed object context I have for my core data, do this. So perform this selector, which is table data did change. All right? So let's do that. Let's add the notifications to my who was in that app. Okay? So we'll go over here to Xcode, if I can spell it correctly. And we'll open up who was in that. And we'll have to change all the preferences so that you can actually see what's going on here. Xcode preferences. Okay. So this is what we had before, right? We had this movies array, which is inside of this table view controller, right? And when we want to load anything from core data, we get an access to our app delegate, which has access to the context, right? So we can get all the movies from the data. So right now what we have is when the view will appear, we go and we reload all of the data. I don't want to do that anymore. Instead, what I want to do is inside my view did load here, what I'm going to do is say, okay, I get access to my app delegate so that I have access to the managed object context. Let's just get rid of this so you can actually, okay, here we go. Right, so the object that I want to be looking at is the managed object context. And whenever that managed object did save, I'm going to call this function table did change. And that table did change is nothing more than what we were doing before inside of this view will appear. So now we're not going to do it anymore down here. All right, so we're running on the Retina. Let's go ahead and make sure that this works. Voila. Okay, so it's got all of the persistent store that we had put in there last time. So now when I add anything into this movie, somebody give me a movie. Any movie at all? Inception. All right, we'll add that movie. Oh my goodness, it's there. And I took all that. Okay, so here I've got an NS log that said, "Hey, handle the change notification," right there, and it logged it. Notifications, we're done with them. Pretty easy. Yeah. All right. So the next thing that we want to talk about are blocks. Blocks of code, basically. So a block is going to be very, very similar to a callback function, if you've ever used a callback function. However, it's not a callback function, right? It's different than a callback function is that a block of code is something that you're going to define, and it gets created at runtime, all right? And any data that you use inside that block, as long as whatever that data was defined inside the scope where that block is created, you're going to be able to have access to that data, but it'll be read-only. Okay, this will all become clear a little bit too when I give you an example. And the syntax for declaring a block is you use the little caret operator. It's not a Lambda function, although it's very, very similar to a Lambda function in the fact that you can pass it around like an object, right? It's almost like a function pointer, but it's not really a function pointer. It's kind of the best of both worlds on all of those that get put together, right? So if you've ever dealt with lambdas, you can pass them around like objects and you can create them, and it's very, very cool and neat. And you can do the same thing with pointers to callback functions. Okay, so let's see what I'm talking about when I talk about a block of code. Okay, so here's the syntax. I can create a block on the fly right here. Now, let's see, do I have some callouts for this? Okay. So the block name that I'm creating is on the fly block that adds 2 ints, right? And I've got this little caret operator right here. And the return type of this block is I'm going to return a float, right? So it's going to return a float. Here's the name of it. And here are the parameter types. It's going to take 2 integers, right? So this right here is just the declaration of that block of code. Now, I'm going to define the code that gets executed whenever I call some of this block, right? So here's on the fly block that adds 2 ints is equal to this caret operator int a and b, return a plus b. Cast it as a float. Okay? So that block is just going to take 2 ints, add them together, and return a float that comes back to me. All right? Now, if I want to use that right now, so I can use this in the same way that you would kind of consider like you would use a callback function, right? Here on the fly block that adds 2 ints, 5, 6. That is going to return 11. And it'll get printed out on the SS log here. Okay? So pretty simple to create a block for what you wanted it to do. Yeah? Have you guys used block before? It's part of C code, but it's not really used a lot. In Objective-C, it's used all over the place, and we're going to see why. Okay, you can also declare a block by doing a type definition, right? So you have this little thing where you're going to type def this block. So this is very, very similar. I have float here. The name of the block is a type-defined block. It takes 2 floats, right? And then I can define this. Type-defined block, block is object, argument 1, argument 2, and I'm going to divide those 2 and return it. Okay? So now when I want to execute this thing that's been type defined, I can say float value equals block is object 22 and 44. Okay? Very, very, very similar context to what was here. It's just I use the type def procedure right here to make it almost function like it would a callback. Yeah? Right? So I could define these outside of any scope and I could get access to them the same way that C would use a callback function or a function pointer. Is this okay? All right. So I type define, it's more like a callback. Here's the syntax to call the block. You can also use a block to enumerate different arrays, right? So if we want to do enumeration, let's say I define this array right here, my array, which is equal to 34.5, 56.4, and pi. Here what I'm going to do is I'm going to create a block and enumerate objects using blocks. So with that my array, there's a special function called enumerate objects using block, and then I give it a block. I'm passing the block as a parameter into this function, into this method, right? So it's going to take an ns number, which is my object that I'm sending in. It's going to take an index, which is the index in the array that I'm at. And I've got this bool here that I can always, if I wanted to set, stop iterating through the array of, some condition, I found an object that I wanted to, or something has occurred, I can just set this to true and it'll stop. Okay, it'll stop enumerating right in the middle of the array, right? But this parameter that's being sent in here is, I'm just going to log all of the float values, right? So here is the float value for that object. Here's the integer value, right? So I can get the integer value of that object, and I can return them, and I'll get them as an ns log. All right? Blocks are pretty easy to use. They're also, yeah, go ahead.
So instead of passing like the little caret and parentheses, could you send in like block as object?
If you had type defined it, and you had type defined it, this is expecting a very specific block structure, which is, this could be an ID. This could be any type, whatever's in your array. But IDX and bool stop, yeah, you could send in the type define. Okay? They're pretty cool. You can have arrays of blocks if you wanted to. They're just like objects. You can define them inside of an array and have them do different things when you call them. All right. So enumerate with block. Some semantics of using a block in your code. I mentioned this before, and I want to kind of ingrain it here. Variables from where I define that block. You can use those variables. So let's say I had some global float value, x equals 5, right? Inside of my block, I can use x. I can read from it. Okay, I can get the value x equals 5. Or let's say in my viewDidLoad, I create a function, or I create a variable, and it's float y equals 6. If I declare that block inside of viewDidLoad, I still get access to that variable, wherever that block is used. It could be used anywhere. I still have access to that variable, even though it's defined in the scope of viewDidLoad. Okay? And Objective-C handles all of that for you.
So is it like encapsulating? You can use it to encapsulate any values or functions or whatever that you want that are on the scope?
You can. And the way that it does that is by making a read-only copy and sending it along with, the block has access to that, right? Or the one thing you can't do is change the variables that are inside your block.
So it's static, whatever things are static.
Yes, unless you declare a float like this. So if I were to give it this underscore underscore block, float some variable, now I have read-write access to that memory, right? So it's not exactly the same, all right? Questions?
So some of these examples looks like you do the same thing with a function in a way. So what would be a good use case here for this
Over a function? Normally, if you can write the function, go ahead and write the function. A lot of times when you declare a block, it's less lines of code. And sometimes it's easier to just follow what's going on, especially if you're making a junk function, right? If you're just making a junk function, you just need it to do something really, really quickly, rather than declare a whole new method or put it in your API or something like that. Just to have these is good. The main reason that we do blocks is for multi-threading, and I'll show you why, right? So the main reason we do it is for that concurrency.
Is it like unclean code if you use too many blocks, because then you don't have to reference it in the header, so it's not like clearly defined what everything does in that?
No, it's not. And the reason that it's not is because it's Objective-C.
Oh, okay.
And Objective-C is it's Wild West, all right? They're kind of okay with this, right? Lazy instantiation, doing blocks all over the place. Blocks are everywhere in Apple's source code for things, all right? They use them all of the time. And they're very convenient, and they're very convenient because if you want to do multi-threading, you can just fire off a bunch of different blocks, and it'll return in one clock cycle, and they're just on a separate queue somewhere running. Okay? So we'll talk about how you do that, how that is. So the one thing that I will tell you about when you're using blocks, if you call a block, if you define a block from, let's say, a view controller, that block won't be deallocated because your view controller has a strong pointer to that block. So automatic reference counting isn't going to come in and see this block object and it doesn't see anybody without a strong pointer to it and just deallocate all that memory. So wherever you call it from, let's say you called it from your view controller, it has a strong pointer to your block. All right? Now, the reason that that is a little frustrating sometimes is because if you want to call a function that you've defined in self from your block, the block is going to carry a strong pointer to self. All right? Does that make sense? Right? So you're going to be using some methods, so it needs a strong pointer to self to be able to go back in and able to access where that method should come from. Right? So it needs access to that class that it was called from. Right? So if I were to call self add 2 integers as a method call, it needs access to me, the class. Now I've got 2 things that have a strong pointer pointing to each other. They will never be deallocated. That is a memory leak. Okay? Also, it's called a retain cycle. Okay? So what you normally do when you have something like that is you just declare a weak pointer to self, and then you use the weak pointer inside of the block. Okay?
Could you not just deallocate it yourself, or you have to use automatic reference counting?
You have to use, when you're using automatic reference counting, you're not even able to call the function release. All right? It won't compile. Okay? So you can't deallocate it yourself. Fair enough? Okay. So concurrency in iOS. What is all this block business? Right? And they're going to be you're going to love blocks by the end of this class. And if you don't, you're not going to like iOS. All right? So there's this thing. So concurrency in iOS, when you want to run multiple things at a time, there's this wonderful thing called Grand Central Dispatch. And it handles all of the operations, right? So you're going to define some operations that you want some to happen, and you're going to give them over to Grand Central Dispatch. Grand Central Dispatch looks at queues of blocks that need to be run, right? So basically, Grand Central Dispatch has a bunch of different queues, and inside each of those queues, these are first in, first out. It's a queue, right? You put a block of code on the queue, okay? And maybe you set its priority. Grand Central Dispatch is going to decide when to dequeue that and run it, okay? Grand Central Dispatch and the Xcode compiler and the whole hardware system of iOS are deeply, deeply connected and optimized, okay? So the concurrency that you get when using Grand Central Dispatch goes all the way down to the kernel, all right? You can't go faster than this with concurrency, all right? And this is the advantage that you have with some of the Apple stuff, right? Because they make their own hardware, they have access to everything that's on it, all right? So that they can build all of this in, okay?
This is how like AppMap works, where they basically have the Grand Central Dispatcher realizing what's in the background and put that at lower priority.
Absolutely. And it's all automatic, right? And it's happening at the lowest level of the operating system. Okay, so for a serial queue, each block is run sequentially, right? So you dequeue it, it runs completely, fully. Once that block is finished running, it goes and it grabs the next thing off the queue. For a concurrent queue, the first block is dequeued and it starts running. And then Grand Central Dispatch decide, hey, if CPU is available, I'm going to go ahead and dequeue the next block. And I'm going to start running that as well. Now, that doesn't guarantee that any of those are going to finish, right? Either of those could finish first, right? And even that, maybe it's got 2 things running. If there's still CPU left, it's going to go and grab another thing off the queue and start running it. Okay?
So this doesn't guarantee multi-threading. It's just if there's enough space to continue.
That is correct. If there is enough space, if there's enough CPU, it will run it. Right? So if you were to write a program, normally you could have a bunch of different threads and they're running. If they would really start to slow each other down, you're not going to get that in Grand Central Dispatch because it won't allow you to do that. You can still do that type of threading, but it's way more involved, and you don't get a lot of the benefits of concurrency that you get with this.
But you can synchronize.
You can.
You can.
You can. These? Yeah, you
The
can.
concurrent queue.
Yeah, the concurrent queue. You can give operations. So like I want to do this synchronously, or I want to call it asynchronously and come back. Or you can also do group threads if you want to. You can do a group queue and then just say, hey, wait till everybody finishes that I need to, and then it'll go. Okay. So the one thing that you have to realize that and I haven't really talked about this, but the main queue, well, I get it. The main queue handles all user interface operations, okay? And it has its own dedicated thread that it is doing them on, okay? No other queue should generate UI changes. That's not to say that you can't update the UI from different queues and different threads. You can, but you shouldn't. And the reason you shouldn't do that is because all of those views and everything that's up there, all the user interface, that is not thread safe. Okay? So some thread could be accessing a view in the UI and setting something, and another thread could come along that's, say, not the main queue and starts doing something to it, and now they're both accessing that memory at the same time. Okay? And you don't really know what's going to happen. So the reason that you do all of your UI stuff on the main thread, on the main queue, is so that everything happens in a deterministic manner. Okay? The only thing that accesses UI elements are the main queue. Happiness? Don't access the UI from a different queue. Even if it runs 99,000 times and it fails once, I'm going to ding you for it.
Because they won't ever use the random happenings as like a random number generator base.
Not that I've seen. There's way better ways to get random numbers, right?
But not clearly.
Question.
When you're using the timer and you had set it up to run on that or run whatever, is the function that it calls going to be run on the UI thread?
That function will still run on the main loop.
Okay, so
All right.
okay to update the UI from that.
So it's okay to update the UI from that. Everyone's like, oh no, I got this project. It's fine, right? The timer itself is counting down, not on the main run loop, right? But that still gets called unless you tell it to do it from another queue. It's still getting run on the main queue. Okay? All right, so this is how it works. You have a serial queue. You have a block of code that you can add. It's going to process it. If there's CPU available, maybe it's going to run these blocks separately. Now, this is truly not multi-threading. Either of these could finish first, and if inside some of these blocks, Grand Central Dispatch sees that there's a function that it could spawn off on a couple of different threads, even for one block of code, it might do that. All right? You could have multiple threads running one block of code. The concurrency that's happening is in how things are dequeued in the operations. Okay? The main queue, let's say you have a block of code that you're adding stuff to, and you can, not just the main queue, any concurrent queue, you can set priorities. Okay, you can set a high priority block on the queue, right? You give it a flag that says, hey, this block is high priority, right? You're never higher priority than the UI. But you can still set something as high priority, okay? So what will happen is it'll process that high priority block. The main queue is a serial queue. So it will wait till that is processed, and then it will go and it will grab the next thing that was in line to be queued. Dequeued. Happiness? Good? Oh yeah, the UI is in sync with one thread, and I did mention that, right? But that is a dedicated thread. Okay, so syntax for a queue. iOS 7, we're kind of right in the middle of a paradigm shift in a little bit. I'm not really sure what Apple's wanting to do here. Everything used to be written in C code for accessing the queues that were there. They've now actually come in and they said, well, this is Objective-C and we're running a bunch of C code. I'd like, something that is a little more object-oriented, right? So there's two ways of doing all of this. You should pick one of them, not use both, okay? Because you're not guaranteed consistency between both, all right? And I'll show you what I mean. So this is how you would create a queue and then add a block to that queue. Right? So you don't have to use just the queues that Apple provides for you. They have a main queue and they have some global queues. You can create your own. All right, so here I've created a new queue with this dispatch queue create. I give it a name, a unique name. And this is going to be a dispatch queue concurrent. So I'm going to create a concurrent queue here with this flag. Right? If you've ever done this before in iOS, they reserved this. It used to not be able to create concurrent queues. You can now, I think, with iOS 6. Then I'm going to call this function dispatch asynchronous. Right? So this block of code is going to use this queue. Sorry, this method, this function is going to call this on this queue. It's going to add this block of code. So I've got a caret, open curly brace, and a close curly brace down here, right? So what I'm going to do here is for int I equals 0 to 3, I'm going to print out some logs. Hey, I'm being dispatched from a queue here that I created. But now I need to go into the main queue and update some of the UI, right? So I'm going to call this dispatch async again from inside my block, because I don't want to execute this on the queue that I'm on. And I'm going to say dispatch get the main queue, and then give it another block. Okay, this is common practice. You're laughing, but it's common. Okay, so I've defined the block here, and I update the UI from the main queue. Questions? Good. All right. I can also do this with an NS operation queue, and I'm skirting around the fact here. This is an object-oriented way of creating a queue that really doesn't use Grand Central Dispatch, but you as a programmer wouldn't know that at all. Okay, so it's gonna work the exact same way. The semantics are gonna be exactly the same. Maybe one day we'll figure out what's going on behind the scenes. Right now, these work exactly the same. So this is a more Objective-C way of doing this, where we have a new queue, NS operation, alloc init. We give that new queue a name, Objective-C queue. I can also set the max concurrent operations for that queue if I want to. If I don't set the max concurrent operations, it's going to try and figure out as many as it can do as possible given the CPU, the load on the CPU. It'll try and maximize it for me. Okay? Then what I can do is add operation with block. And I create a block. It gets added to the queue, and it gets run immediately, as fast as it can. One thing to notice here, this dispatch asynchronous right here, this is a non-blocking piece of code, right? And not only is it non-blocking, it returns in one clock cycle, okay? This adds this block to the queue in one clock cycle and returns, and then keeps chugging along with whatever you wanted to do, okay? So I create a new queue, define block, update the UI from the main thread. Now, the way that I call the main thread from here is I go self perform selector on main thread, and I give it a selector, right? So this is slightly a little more work because you actually have to, say call a function here, and that function is set my label, right? Rather than just setting the label from inside the code here, okay? But it's more object oriented. Questions? Oh, like inside here, can I use this?
No, so just have the block, that block somewhere in that.
Oh, like actually, like everything that's inside this block just be inside this function? Absolutely.
I'm just saying instead of having the function, use the block there.
You can't. You cannot. You cannot. Yep.
So if you're requesting the creation of a queue and then you're just pumping blocks into it, what does the operating system do if you're taking up too much stuff? Does it just start not allowing blocks and deleting blocks from the queue?
No, you can fill up the queue and you keep filling it up, and it's got other stuff to do. And whenever that stuff frees up, it's going to go to your queue and try to do whatever it can, right? It's going to try and get rid of the blocks that you have there and execute them as fast as it can. And if you're just holding your phone, all it's doing is processing your queue.
Okay.
Right? If the user's interacting with it and doing some other things,
and because it's that way, it'll never lock up the UI, so it'll never get shut
it will
down
never
by
lock
us.
up the UI. Well, yeah. It's difficult to lock up the UI because of that. Okay? Okay. Okay, there's also queues, so if you don't want to create a queue, you can also use some of the global queues that are out there, and that's how you get access to a lot of different priority level queues. right? So in this is all one line of code here. I know it doesn't look like it, but it really is one line of code. Dispatch async, and then I call this dispatch get global queue priority default. And then I send in a 0 right here. You'll always send in a 0 until they tell us what that's for. Okay? Maybe they have already and I just have ignored it, but maybe there's something there. And then you can put your code in here. Now, even though I've called get global queue, I'm not on the main queue. All right, so if I want to do UI, I still have to get the main queue. Okay, there's other priority levels that you can do. So low, default, high, and background priority. Don't set yourself as background priority if there's anything that you want to get done sometime, anytime. Okay, if there's something that you want to be considered low priority, what happens is anything that's high priority will get dequeued and run first. Then if there's nothing with high priority and it's default, that'll do it. It's kind of how you would expect. If there's nothing default or high, it'll do the low priority stuff. If there's nothing else in the queue, it'll go to the background stuff. Okay? You probably will never use background, but it is there. Okay. And I already went over this, so we weren't on the main queue. It's a global queue, it's not the main queue. Okay. Before we go into a demo of using that, I also want to talk, we'll just go into the demo. Yeah, we're just going to go into the demo. All right. So let me close down who's in that. And let's open up this threading block demo. All right. So inside of this, let's just go to my storyboard. It's a really, really complicated program. It is one view controller, all right, with a label in the middle of it. Inside of my threads demo view controller, which is the main storyboard view controller, the only view controller inside of this whole project, I've got a couple of things. I have an outlet, right, that goes to my main storyboard label. And then I've got a bunch of stuff that I'm doing inside here in view did load. Right? And a lot of those things, and I'll post this code, this is all of the code from the slides on creating blocks and using blocks. Down here, in view did load, I'm creating this dispatch queue, which is just exactly what we saw before. I'm creating a concurrent queue. And then right after that, I'm creating another queue using Objective-C. This is something I told you never to do. Right? So if you're going to use dispatch async and this dispatch queue create, all of that stuff, stick with that. Because if I were to say, dispatch async and then add something to the main queue, and then right after that, the immediate call, I were to say perform selector on main queue, you're not guaranteed which of those is going to go on the main queue first. Does that make sense? If I do dispatch async, get on main queue, dispatch async, get on main queue, I am guaranteed that the first one I call will go on the main queue, then the next one. Okay? Most of the time, whatever you call first, I think it's 96% of the time, that one will go on the main queue first. But you're not guaranteed that. Okay? That may be a bug that Apple just hasn't fixed yet. All right? So what we're going to do here is we're going to print a lot of NS logs. Okay? So each of these blocks of code, each of these queues is going to say, I am being executed from, this is being executed from a concurrent queue. I am being executed from a dispatch queue from Objective-C. This one is going to be a global concurrent queue. Okay, and it's going to print those out, and we're going to see when they happen. And then at the very end of this, inside of the end of view did load, I'm going to have this, I am being executed from the main queue. All right? Or let's just say view did load. I'm being executed from view did load. And let's run it. Okay, so, wow, you can barely see that. I have no idea how to update the NSLog preferences for text. Sorry. But basically what it says here is the first thing that gets run is I am being executed from the created concurrent queue. Okay, so that got run first. Then my view did load. That got run. Then I've got some other things from the global, oh, the dispatch queue from Objective-C, right? So you can see that you have no idea when the things are going to be executed, okay? But they will be executed in some way, shape, or form. If you really need control over all of that, make a serial queue, okay? Any questions on running multi-loops? It's pretty easy, and it's really, really powerful, okay? Because all of this is optimized and happens down at the kernel. Okay.
If a serial queue just does everything in order, how is that different from just writing a robots?
Because what you can do is you can, with Objective-C, you can pause and resume queues. Now, once a block starts operating, it's going to finish, right? There is no good way of stopping that code unless in that code it's checking something and it says, oh, I should stop running, right? So what you can do is you can set up an entire thread of things that you want to run, have it paused, and then resume it sometime when you need that to happen. All right, so you can create a serial queue of all different operations, or even a concurrent queue and then resume it later if you wanted to. Right? Most of the time, we're just going to use it so that we don't lock up the UI. Right? So if we're doing something, we need to go do a fetch request over the internet. We don't want to do that on the main queue because it will block the entire user interface from functioning while we're going out to get that data. All right? Or if we have some massive signal processing operation, we don't want to do that on the main queue. All right? Okay. Doing well. Here we go. Objective-C++. Okay. So everybody, if you didn't know Objective-C before this, now you're finally getting used to Objective-C, and I'm going to throw this new language at you, which is Objective-C++. In reality, that's not what I'm doing. It's just C++. Okay? It is exactly C++. There is nothing else around it. It's just now you can call C++ from Objective-C. Okay? Very, very simple. Everyone should go, oh, all right, nothing new. The only thing that we need to do is tell the compiler that we're using C++. Okay? So when we create a class, we're going to do any include statements. You'll notice that I said include statements, not import. Right? We're going to use include. It's C++. You're going to change your extensions. This is probably the best way of doing this, I think, because when someone sees your code, they're going to see that your extension is .mm instead of .m, and immediately they know that you use C++ code in there somewhere, or else you wouldn't have named it .mm. Okay? Now, automatic reference counting when you're using C++ is not going to help you when you use things like malloc, calloc, or the new and delete functions, right? When you call something and you say new, you've got to delete it somewhere. Okay, so what we're going to do is explicitly call the dealloc function, which is something you've never used before because we've been doing automatic reference counting. We never had to deallocate anything. It deallocated it for us, right? So, but in the dealloc function, we don't have to deal with releasing the memory of our own class. That's all gets done for us. But we're going to need to call our destructors or delete functions for things that we've created, C++. Okay, happiness? So let's add a C++ code to our multitasking code. I have in here a wonderful example CPP class. All right, so here's the .h file. And by the way, if you want to create a class, you can just go to Command New, and then you can go down here to C and C++. Oh, sorry, iOS. C and C++. You can create a header file, C, all that jazz. Okay? So that's all that I did. So the class is an example CPP class is the name of the class. And in my public API, I have this function called access, and then I have the constructor and the destructor. Okay? Is this new to anyone? Awesome. Okay. I didn't think so, but I gotta check, right? Private is the number of accesses, the number of times that I've called this function. That's all I really want it to do. And that's all that it really does right here. Okay? I don't even have to deallocate anything because I didn't use malloc, calloc, or new in here. Right? But my destructor is right here, just in case I wanted to do any of that. Okay, that destructor I'm going to want to call in dealloc from wherever this class is instantiated. So if I go up here, this is what I can do. Under my @ interface here, I'm going to create a property. And that's my example CPP class. It doesn't know what that is. So I need to include example CPP class.h, right? And so now I can get access to this example CPP class. All right, and I'm going to call it my CPP class. That's the instantiation of it. Inside view did load, I'm going to say my CPP class equals new example CPP class. And then I'm going to create a timer. And that timer, I'm going to call this function access my CPP class. All right? So every time that access CPP class gets called, it'll be access. I'm going to do it every second. And it repeats, yes. Questions on that? Happiness. Pretty simple. So here's what access CPP class looks like. Int I equals my CPP class access, right? And it's going to return the number of accesses that it has, and I'm just going to print that out. You'll notice I'm using a printf statement right here. That's going to print to console window in the same way that nslog does. nslog has a lot more information. Okay? Oh, and I want to call my dealloc, right? So here's what I'm talking about. This is the dealloc for the class right here. It's giving me an error. Replace delete with undelete. No, that's not what I wanted to do. I need to tell the compiler that this is C++. So .mm. You know what? Here, I'm going to leave it as .m. When I do this command build, it's going to go build feld, right? And here's what it gives me. It says IOStream file not found. Okay? When you ever don't tell it that you're using C++ and you try to build something, it's going to give you some cryptic error. All right? It's not going to tell you, oh, are you using Objective C++? No, that's not the first thing it goes to. It's going to try and compile this as C code, but it's C++ and has no idea what to do with it. Okay? So I'm going to declare this as .mm. I'm going to build it. Build succeeded. What? Excellent. All right, so we've set a timer and we're just going to have this thing fire off, right? And now I can call things like delete my CPP class. You'll notice that this right here, the delete isn't highlighted, right? If I go back up here, okay, it did get example CPP class. The IntelliSense for figuring out everything with Objective C++ in Xcode is a little bit buggy, okay? Sometimes it highlights the right words and sometimes it doesn't, okay? And if you restart Xcode, usually that will be fixed, all right? But you also lose the ability to refactor code, okay? When you've got Objective C++ that you're using in a .mm file, and you say, oh, I want to rename this class function, it's going to be like, no, you lost that ability when you told me you were using Objective C++. There's too many rules and too many things that you can do with C++. I don't know how to refactor your code anymore. That's what it's telling you. Okay? It's something that Visual Studio can do, Xcode cannot. All right? So, let's play. Yes, I want to stop it. All right, so now I've accessed 1, 2, 3, 4. I'm using C++ from Objective-C. No one's mind is blown. I should get like applause for something like this. All right. That was so weak. All right. Ooh, that's witty. All right. So we added that to our multitasking code. We're all happy with ourselves. We know how to make concurrency. We can do some stuff with it. Let's talk about CoreAudio. We are done with UI. Is everybody happy? This class is about to slow down. Okay? Everyone take a deep breath. Or if you already know how to do this, you're like, thank God, something else. Right? If you've already seen Objective-C. Okay. So Audio sessions in CoreAudio is completely overhauled for iOS 7, which means somewhere like 3 months before this class, I had to relearn everything. All right, so I did. Here we are. All right, so,
Huh?
Is that good or bad?
we'll see. I think it's good, right? I think a lot of the changes I'm very, very happy with, okay? There's this thing called audio sessions, which basically an audio session is a shared instance that you have in your application that tells iOS how to deal with your app using audio. Okay, so you're going to say, hey, audio session, I want to use the microphone, or I want to use the speakers, or I want to use both. And it's going to try and configure that so that any other app that, say, has background music playing either doesn't get interfered with or works side by side with the audio that you're using. Okay, very, very powerful. You're going to do things like you're going to set the category. So you're going to tell it whether you want to play, whether you want to record, whether you want to do both. And you're going to choose options like, do you want to mix with ambient sources, right? So if someone's playing iTunes, you can play it in the background, and they have a song playing. When your app comes up, do you want that to stop playing? Do you want to take over audio? Because if you do, I need to know that, right? Or do you just want your audio to be on top of that? You can also do things, what's very new in iOS 7, you can set the audio route now, right? So the 5S has, I think, 3 different microphones on it. You can choose which one you want to use. All right, you can't use them all at the same time, but you can choose which one you want to sample from. Pretty cool. You can choose which output you want to be, right? Do you want it to be through the speakers? Do you want it to be through the headphone line, even though headphones might not be attached, right? Do you want it to be through, I don't know, you're doing AirPlay and you want it to go through your TV? Simple flags. So you set the specific hardware within the audio route. There are some stipulations for this, right? So I cannot sample from, say, the microphone here and then play on the speakers, say the headphones, okay? There's some stipulations that the hardware just doesn't allow you to do that, okay? So there's some audio routes where you're trying to go from one microphone to the speakers that you can't do, right? Because there are hardware changes that when you plug in the audio jack, it overrides some of the audio routes, like the physical connections. The firmware doesn't allow you to have an audio route between, say, the microphone that's on here and the speakers that output right there. Okay, that's something that may change very well in the future, but right now it's a limitation. I'm getting frowny faces. You guys okay? Okay. Once you declare an audio session, you're going to have to set up what's called an audio unit. And this is something that is going to allow you to configure the output and input of your class. So you're going to be able to set stream formats, like what's the format that you want to read from the audio card from? What's the buffer size of audio that you'd like to pull from? What's the sampling rate that you want to have? You're going to need to initialize memory for all of the audio buffers that are there, and we'll talk about that. And we're actually going to use callbacks, right? Every time now when we fill up a buffer, I've got, X samples of audio. I need to call your callback function so that you can have access to it and you can do something with the data. Okay? All of that's part of the CoreAudio framework. Right? So let's do this pictorially so we have a better understanding. So here's iOS, and it's running, and it's at every single application, let's say everything on your phone, and they all want to use the audio. Okay? You have audio session management that is controlled through iOS. So if you have some background audio that's right over here, it's going to send a request to the audio session management that it wants access to the speakers. And your audio session management's going to be like, okay, you can have access to the speakers, and iTunes can play in the background. That's great. Here's your app. Let's say you've got something in your app where you want audio from the microphone. You want to grab it and then play it directly on the speakers, right? A little pass-through, right? Maybe you want to manipulate it and then output it. So you send a request to the audio session management. And maybe during this, you want all that music stuff to turn off. So you need to tell it whether or not you're going to play nice with other apps. Okay? And even within your app, you've got 2 things that want to do something with audio. Let's say I actually want to control the songs that are being played from your iTunes library. Well, I'm going to make another request for the audio session management. Right? And I'm going to say, I want to do that too. And I want those to play nice with each other. Okay? I want you to allow the playing of those to happen, maybe even happen in separate queues, right? And then I'm going to be just kind of taking a bunch of samples from the microphone and throwing them out there to be played onto the speaker. And I want you to handle all of the mixing for me, and it will. And that is impressive. Okay? If you've ever done hardware audio mixing before between applications, it is not just a matter of adding signals together. Okay? It is difficult. It is involved. Okay? iOS, you can write as many samples as you want. It's got audio that's playing in the background, right? If you were to add them together, sometimes it might clip. You might get different frequencies. It's going to mix them together in such a way that the user cannot tell the artifacts that would be generated from the mixing of that audio. Okay? Very powerful. Very cool. And you get it for free. Right? And it's involved in the hardware. They have specialized hardware that is doing that mixing on the phone. Questions?
How many songs can I play at the same time?
How many songs? I've never actually tried. I know you can do 2, but you could probably do more. The only thing is you would have to configure separate audio sessions for each, right? So if you want to play something from the iTunes library, that's great. You get 1 song. Everything else has to be like songs that are in your code, and you're going to read the file and play it. Okay? Right? So if you want to make a DJ application, right, and you want to be able to overlay things, you can. Absolutely, you can. But it's going to be a little involved to get access to those.
Wait, so you can't have 2 references to the iTunes library in terms of picking stuff out of it?
In terms of, well, it depends. If you really, at their high-level API that allows you to play songs from it really, really easily in like 4 lines of code, 1 song at a time. If you want to dig down deep, you're going to have to use something else.
Like copied in core data or something and then pulled from...
Yeah, but it's not going to allow you to copy songs from iTunes library. If you want to copy songs from the iTunes library, you wouldn't even know where to begin. The first thing it does when it copies over songs is it gives it like a ridiculous identifier that only it has a database lookup for that song. So even if you knew which song to look for, you would have no idea what the hash code was to go get it.
Okay.
And even if you could get into that library and look at it, right? Like Apple is in the business and they make a lot of money off of selling people songs. All right? Your app is not going to go in there and copy stuff over. Okay?
That makes sense.
Okay. Fair enough. Okay, so how do you deal with the hardware? How much time are we doing? Oh, we're doing awesome. Yeah. Okay, audio unit. So you have an audio input buffer. Okay, so let's say you've got a couple of buffers. On the very hardware side, the sound card, what it is doing is it is filling a buffer up with audio. Okay, let's say this is from the microphone. Once that buffer gets filled, right, let's say, I don't know how many samples that is. 8,000. 8,000 samples that it just collected from the microphone. It's going to send that to an audio session callback. Whatever callback you registered with it, it's going to call you so that you have access to that data, you can copy it over, do whatever you need to do with it. While that's happening, it's filling up another buffer right here with audio during the hardware. Right? And the second that is filled up, it's going to send that off to your audio session and fill up. And it's just going to cycle back and forth right here, double buffering. All right? And going in there and filling it up with as much audio as you can process at one time. Because that is the process that it's doing, your audio session callback should be very, very fast. Okay? You don't want to do any kind of blocking code inside there because you're going to start dropping samples from the hardware. All right? The sound card's going to send it to you. Your procedure's already running. It just drops that entire buffer of audio. Okay? You don't get it. So what you can do is copy over the samples, convert the stream format to whatever you want it to be, and you want to exit from that call as soon as possible. So you don't want to do things like allocate memory. You don't want to take locks. You don't want to spawn threads. You don't want to waste time. You don't do anything inside that callback.
So the cycle between the buffers is at a certain frequency. Is that a known thing? How fast that?
No, and it's not even known if it's double buffering. It could be triple or quadruple buffering right back there.
Well, that makes sense because you just make one buffer longer than
Yeah.
the case.
Yeah. Yeah. You can set a preferred buffer size, and that's exactly what it is. Your preferred buffer size, and it will go back into the hardware and it'll be like, well, we can't really do that, but I'll give you this. And then, so you set up the audio session with your preferred buffer size, and it will go in and it'll say, you can query it, say, hey, what did I get? and you can say, here's my buffer size.
So it's just whenever it fills up, it dumps.
Yep, it fills up, it dumps as quick as it can. Okay. So all of that interface, that callback, it's written in C code. Okay, it's not Objective-C. It's written in C. Part of it is now written in Objective-C for iOS 7. All right, and they deprecated all of the other C functionality. Okay, but essentially they made an object-oriented model for this. Okay. So what do you want to do inside of this callback function? Everybody know what a ring buffer is? Who knows what a ring buffer is? Who's used a ring buffer?
Is it a buffer in the shape of a ring so that the reference can pass around?
Bam.
Oh, okay.
That's exactly what it is. All right. So let's say you have this giant buffer that you want to fill data into. Well, whenever this callback gets called, you want to go in and you want to fill that ring buffer with as much data as you can, right? And then you keep a pointer to where you were. Whenever your callback gets called again, you fill it up some more. You fill it up some more. And it's just basically in the shape of a ring. When you get more data, you start overwriting the data that you got. And you keep going, you keep going, you keep going. Okay? That's a ring buffer. And that's probably the best and simplest way. Because now, whenever you want to do processing on that data, you don't need to create and allocate and move data around and kind of shift it. You can just process it right there in place. Okay? And when you're dealing with audio, it's really important to process it as quickly as possible. And the reason I say that is because audio generates a lot of data very, very quickly, right? If you're sampling at 44.1, you are getting 44,000 samples per second that are coming in and being copied over that you want to deal with. Questions?
Could you not just like put it all into a block and then put it on a queue and just have it process whenever?
Hold that thought, because that's exactly what we're going to do. Okay, so audio unit format. Before we do that, audio unit formats. We have the microphone, okay? So let's say we're sampling from the microphone, and we want to do that playthrough example where I'm going to take, microphone data and I'm just going to play it on the speakers. By the way, don't ever do that, okay? Because if I snap like this, it's just going to, do you know what I mean? You're gonna get an echo and reverb, and it's just gonna go crazy, right? It's an unstable system. All right, you're just gonna be feeding in more audio, and it's gonna get louder and louder and louder, and that's why you get that. And if everyone in the lab did that, I'm gonna go crazy. Okay, but if you wanted to play that, let's say you wanted to do that, well, you have to put this into an interleaved format, right? If you want to play it on the speakers, you have a left and a right channel. Microphone, single channel. Speakers, left and right channel. So you have to get this interleaved process where the blue is, say, the left channel and the red is the right channel. Okay, and you have to interleave that and you have to double up the data if you want it to play the same amount of data, right? So your data rate is shifted. It's kind of changed around. The way that you get data from the audio card is in something called Q8.24. Okay? Have people used Q8.24? I see one nod. I'm going to guess you're the only person that has done Q8.24. Okay? Anyway, the first 8 bits right here are the integer number at which that is at. And everything after it, the remaining 24 bits, are the fraction of the integer that it is. Okay? All right? So the microphone is basically attached to an analog to digital converter. Right? And so it digitizes that continuous audio value into this, and it's 32 bits.
Size of a register on a microprocessor.
Size of a register, right? That doesn't mean you actually have 32 bits of precision here. There's noise on the audio in the channel that you don't actually have 32. You're probably lucky to get 16, okay? We'll go over all of that next time if you have no idea what I'm talking about. Okay. Audio made easy. Everything that I just told you about, I'm not even going to make you deal with in this class. All right? We're going to use some sample code that I was lucky enough to find on the internets. All right? And it's called Novocaine. It was made by someone with a very advanced sense of humor, right? They said that it was a pain to work with CoreAudio, and so they made this class, and they called it Novocaine. And I gotta be honest, it's really, really well written, and we're gonna use it. Okay? It makes this audio stuff easy, and I mean really easy. Okay? What we're gonna do is, look at this. They even made an implementation of a ring buffer for us. Oh, wow. This is gonna. So I'm gonna have this class called Novocaine. I'm gonna call this Audio Manager right here. All right, so I've got my little class. It's not instantiated yet. So now I'm gonna go down here and say Audio Manager, Novocaine, it's a class function, Audio Manager. And it sets up everything for me, my entire audio session. My entire audio session, my unit, my callback, all set up. After this line of code, it is ready to go. I'm also going to create a new ring buffer of, whatever buffer length here. This is a constant, K. You put a K in front of something, that's a constant. Okay, it's a pound defined somewhere. All right, so I've got a buffer length for my ring buffer, and I'm going to say it's single channel, one channel, right? Here is where I really like Objective-C, because when I'm in C++, you don't know what these variables are from just reading the code. You got to go back and look at the documentation, right? So this is ring buffer, the length, and the number of channels. Happiness? Declare the class, set up audio, and init the buffer. Right? And you don't have to use ring buffer with this class, by the way, but we're gonna. And then inside of view will appear, we're going to set up some functions. And the reason we do it in view will appear because we want to wait till the very last second before we set up these audio blocks of processing that we want to do. Okay? And what we're going to do here is I'm going to say audio manager set the input block, and I'm going to get data. I'm going to get the number of frames in that data, and I'm going to get the number of channels in that data. Right? So this input block comes from the microphone inherently. Right? So right here is data. If it's single channel, num channels equal to 1, then the number of frames inside that data is the buffer size. That's going to be a float array of size num frames. Okay? You notice I have not mentioned Q 8.24 in here anywhere because it's already converted over to a float array for you. And it's as fast as possible. Okay? I've got this output block here, which say, hey, I want to write to the speakers. Well, num channels probably going to be 2 right here, depending on how you set up your audio session. Num frames, right? So the number of samples, and then data right here. And you can, whatever you set as data is going to be played on the speakers. So if I did something like this, microphone samples, data to write to speakers. So if I added some code right here that said ring buffer, add new interleaved float data, the frames, the channels, it will add it into the ring buffer for me. Ring buffer, fetch interleaved data, and store it into data. And it's this number of frames, it's this number of channels. That is a playthrough example. I did that, I don't know, 13 lines of code. All right? Oh, by the way, don't go get Novocaine on the internet. It's not updated for iOS 7. I will give you the updated Novocaine version for iOS 7. Okay? If you go get it on the internet, it's all deprecated right now. Whoever's managing it isn't managing it. All right? So I updated the whole thing. Okay? Okay. So Novocaine uses C++. Well, parts of Novocaine use C++. If you're going to use ring buffer, that's a C++ class. Okay? So if you want to use it, you're going to have to drag it over into your project. So you're going to go into Blackboard. You're going to get access to this. You're going to download it. And then you're going to drag those files over into your thing. And what you're going to do is copy items into the destinations group folder. Because you may want to go into this Novocaine file and manipulate some of your audio session properties. Right? The one thing I'll say about Novocaine is setting up the audio session, they're expecting that you're sampling at 44.1K and you want to do it as fast as possible. Okay? Normally you are. Not always. So you'll copy over the items, and you'll just click this copy when you try and drag it in. Okay? And it'll make a copy and send it over. The next thing you're going to do is, inside of your project, you're going to go over, you're going to click on Novocaine. So the example of my project was Novocaine example. And you're going to go into build phases, and everything that's inside Novocaine does not use automatic reference counting. So you want to tell the compiler, don't try to use automatic reference counting. So you give this little compiler flag, F no Objective-C ARC. All right, disable ARC for these files. Wherever you use C++, rename that view controller to .mm so that it compiles and it knows that you're using C++. How are we on time? 4:39. We got time for an example. Oh yeah. Oh, and get the source from Blackboard, which I'll post up right after this lecture. Novocaine setup demo. All right, let's do this. Let's just create a whole new project since we've got a 10 minutes. 10 minutes is a lifetime.
You should send your here update for you.
And then
What, like a general public license type thing? Come on, what am I doing? No, I should. I really should. Let's create a new Xcode project. Single view, yeah, sure, why not? Let's call this play Rolling Stones. Next.
Are you gonna play the Beatles in this one?
That's really funny, actually. All right, so play Rolling Stones. So the first thing that I'm going to do is go in and grab Novocaine. So I actually have Novocaine in another project, which I'm just going to open and drag over. Okay, you can drag it over from Finder too. Play Rolling Stone. Open recent. All right, so let's do this. So I'm going to grab all of these files right here. Shift. I'm going to drag them over. I'm going to put them into sibling right here. Okay? In the hierarchy. I just put it right above Play Rolling Stones, right? So I'm going to copy those into my destination folder. I'm going to finish. Excellent. Okay, so now I've got all of that in there. You know what? Let's clean this up. I want that to be called Novocaine. I'm going to right click, new group from selection, and I'm going to call that Novocaine. All right, excellent, wonderful. Very, very happy with this. Okay, so the next thing that I'm going to do is I'm going to go down here to my view controller, and in the @implementation section, I am going to, well, first thing I'm going to do is import it, right? So import, don't know why it's not auto doing that, but whatever. So let's create Novocaine. We'll call it Audio Manager. All right. See how long it took for actually to catch up with that? Okay, so Novocaine Audio Manager, right? It's not complaining to me right now because Novocaine is a .m file. Novocaine itself is Objective-C. If I use ring buffer, immediately it's going to not use Objective-C. It's going to use C++ and it's going to complain. Okay? So what I want to do here is set up my Novocaine examples. So Novocaine. I know that I've got a code snippet for this. Well, maybe I don't. Okay, well, it's easy enough. Audio Manager is equal to Novocaine. And what did I call it? What was the setup? How did we do it? Audio Manager. Okay, everything after that now is set up. Okay, so my entire audio session is now set up, right? So I'm not going to do anything about memory warnings. Instead, what I want to do here is maybe in, let's find view will appear. Okay, there's view will appear. So in view will appear, I want to call all of my set stuff. So the first thing I want to do is actually call my super function, right? My super, what I've inherited from, oh, come on. All right. So play audio song. I do have a code snippet for that. Okay, so I'm going to use something I didn't tell you guys about, which is also my audio file reader, which is a C++ class. That's part of the Novocaine package. Okay? The reason I didn't tell you about it is because it's so easy to use. All right, so let's create a file reader. So we're going to create an audio. I've got to import it. Yeah? So I'm going to import my audio file reader. right here. And we need to instantiate that, right? So audio file reader There, finally caught up. Okay. All right, so what I've done here is file reader. I'm going to audio file reader, alloc, init with audio file URL, input file URL. Input file URL I got from this. All right, so I'm going to create an NRL and I'm going to say, okay, go to the main bundle and URL for resource, whatever song I want to play. Okay, so I need a song, right? And this NS main bundle we used a little bit before in core data, right? So what I'm going to do is drag over a song and put it in my supporting files, right? And this function right here, main bundle, get URL for resource this with extension that, will go and find that song that I've put in my bundle, okay? So I know, oh, come on. There, Rolling Stones, put it on the desktop. Yeah, copy it over. So we're going to copy it over. The name of that song is Satisfaction. Please don't play it right now, guys. Just hold on. Hold the horses. All right, so we're going to call it Satisfaction. Does anybody not know who the Rolling Stones are? All right, good. You, not the way that I asked that, no one would admit to it right now. Anyway. Okay, so basically what I'm going to do here is the only thing I need to do here is set my output block, and I'm going to ask the file reader to retrieve fresh audio samples and set those into data. Okay? And then I could nslog if I wanted to, something right here. That is it. I've called file reader and said, hey, go refresh the data and load me some new data samples and put it into data right here, which gets sent out to the speakers. All right? Let's run this on an iOS device so that it's actually there. Whoops. So I'm going to run this on my phone. I'm going to see if I can use AirPlay with my phone as well here, but it may not. Yeah, all the music I listen to on that. Okay. Put it up. Right, so if I were to try and do this, will it work? No. Why not? Because my view controller is not a C++. Okay, so I'm going to go here. I'm going to add .mm, right? So now it's C++. I'm using audio file reader, which is .mm. It's a C++. Okay, so I need that there. Great, awesome. So now I'm just going to build this. Everything's going to work really, really. Oh my God, what's going on? ARC. Oh, it's not happy with me. Shenanigans. Yeah, shenanigans. You actually got me to say shenanigans in lecture. Great. Okay, so let's just take this. We'll set this up. So everything in here, we want to give the compiler flag F no Objective C ARC. All right. Will it build?
Never mind. We don't need that for, oh, because we're not creating, we don't have any, we don't need.
All right, so let's see if this will actually work. I'm going to do this on my phone. It's really important from now on you do this on the device, okay? Because the emulator is going to try and emulate the audio card on here, and it's not going to do a very good job because it has an audio card and it's different, and emulating the audio card is just weird, right? This thing can sample at 48,000 samples per second, but it can't truly sample at 44.1. So you'll get weird errors when you're doing stuff on this emulator versus the device. From here on out, we're using the device. So we're going to go to Eric's phone. That's me, by the way. I'm going to play the Rolling Stones, and if with any luck, this will actually work. Oh, what happened?
Not generally.
Well, yeah, it's not interleaved. What is it? What's it doing? It says play Rolling Stones would like to access the microphone. I didn't write code for this. I didn't write code to, if the user says no, I didn't write code to handle that. It's just going to error out and crash. All right? Apple has privacy settings for the user, and they default to the user. Okay? I'm going to say okay. It's not very loud, but it is playing.
Did you just like multiply the samples?
Yes, you can. Absolutely. Yeah. In that output block, I could call and we'll talk about that next time, the accelerate framework. I can give it, so I'll do a bunch of C codes to enhance the volume or take the decibel value or take an FFT or whatever the hell I want to do with it.
So that says not interleaved. Does that mean that you're not using like the stereo and it's just using one?
Yeah, what that means, the microphone data is not interleaved,
Oh,
but it's handling all of that for me. Right? Well, actually, so yeah, the buffer that I use is not interleaved. I could set this as interleaved. I just have to go into the Novocaine to do that. And there's ways. Happiness? I'm just going to leave this playing.
It's so quiet.
It is so quiet.
I can barely see it. I'm right.
I should turn the volume up on this thing. You don't think it's playing? I'm gonna hold it right down here next to my microphone. If you look at the video for this lecture, it's gonna be like blaring the Rolling Stones. All right. Questions, comments, concerns? Your first assignment is due Friday. Woot. Yeah. All right. Good. Happiness. My office hours, I've had lots of people, so I'm happy. All right? All right. Fair enough. Let's go. It's lab time.